Does upset prevention recovery training, or UPRT, really enhance manual handling skills in professional pilots? Why UPRT is a critical facet in building a more able, skilled, and tested community of pilots worldwide. Hello, I'm Scott Bonsai Derringer, and I am an Aviation Performance Solutions Emergency Maneuvers Training and Advanced Spins instructor pilot. I've got an ATP license. I've been a Part 135 airline pilot, flown a variety of civilian aircraft. I am a master CFI aerobatic with almost now 1,000 hours of all-attitude instruction given in both the Extra 300 and the Extra 330. I'm a former U.S. Air Force F-16 pilot, and I've got a master's in aeronautics from Embry-Riddle Aeronautical University. I appreciate the interest and attention. So this is what we'll cover in this presentation here. First and foremost, we need to define what manual flying skills are, so everyone's on the same page here. Once we do that, we'll look at some case studies of recent mishaps due to poor manual flying skills. We'll cover some deficiencies present in current traditional flight training. And then we'll talk through some facets of upset prevention and recovery and how they fill those voids that contemporary traditional flight training leaves and how they affect manual flying skills development. So again, does UPRT really enhance manual flying skills in professional pilots? This is a broad question, encompassing both objective and subjective subject matter, which spans many different facets of aviation. First, the term manual handling skills needs discussion and definition before we explore the rest of this. Manual flying is generally thought of as those flying abilities a pilot uses to fly the aircraft only by reference to the raw data presented in the forms of airspeed, attitude, altitude, vertical speed, and so on, through direct manipulation of the controls without the aid of automation. This automation includes, but is not limited to, autopilot systems, autothrottles, and the variety of flight management systems currently equipped in many modern-day aircraft. These skills include complex problem solving in a crew environment, with time as a critical factor. Basic navigation equipment usage and manual trim adjustments can be considered manual flying as well, depending on the sophistication of the equipment, really. Taking this a step further, especially as it relates to modern aviation, a pilot's flying technique may combine the already mentioned manual flying skills with combinations of automatic speed and direction control and guidance. These combined inputs usually occur through individual pilot habit patterns or preferences, procedural requirements, operational standards, or when automated systems fail. The latter of these instances, the failure of automation, is a circumstance that is rare, but is cited as a contributing factor in several recent and deadly crashes. The failure of automation, or perhaps even worse, degraded modes of automatic flight, make the pilot's manual handling skills incredibly important, and are often the decisive factor between life or death in an upset. So, examination of some recent fatal accidents in the industry can provide very valuable insight into the importance of manual handling, especially for pilots flying more sophisticated aircraft with advanced flight control and automation systems. The first one we'll look at is China Airlines Flight 140. We'll follow that with a look at Colgan Air Flight 3407, and finally, Air France Flight 447. The first example here, China Airlines Flight 140, was an Airbus A300-600R, which crashed on an approach to runway 34 at Nagoya Airport, Japan, on April 26, 1994. The co-pilot, who was the pilot flying at the time, after several inappropriate activations of the go-around mode on approach, and several subsequent cautions from the captain, inadvertently selected the takeoff go-around or toga mode on the approach. The aircraft pitched up and immediately stalled. This led to a loss of control and a tail-first impact with the ground. The crew failed to recognize the stall or apply appropriate manual handling skills on manual approach. The reliance on automation and unfamiliarity unfamiliarity of the crew with manual handling characteristics of their particular aircraft led to the deaths of 264 people and 7 more injured critically. The second mishap is much more recent. This is Colgan Air Flight 3407, which is a DHC-8-400, which was on a code-share agreement with Continental Airlines, and it crashed into a residential area near Buffalo Niagara International Airport while on an ILS approach at night in visual meteorological conditions. The aircraft entered a stalled condition due to improper power settings and airspeed control, and the crew reacted by pulling on the control column, which increased the angle of attack further and worsened the stall condition. The aircraft responded by rolling one direction and then the other, culminating in 105 degrees of bank and 25 degrees nose low before impact with the ground. Following the crew's inappropriate reaction, the crew lost control of the aircraft, which resulted in the fatal crash that killed 50 and one person on the ground. Finally, and much more publicized worldwide, is the crash of Air France Flight 447, which was an Airbus A330-200 that departed Rio de Janeiro, Brazil, on the 1st of June 2009, and crashed into the Atlantic Ocean en route to Paris, France. After a two-year-long multinational effort to find the crashed aircraft at the bottom of the ocean, the wreckage was finally recovered. The data recovered showed that a loss of airspeed sensing resulted in the aircraft's fly-by-wire system degrading to a mode of control with fewer protections than the crew was used to having. At 35,000 feet, the aircraft stalled, and the crew responded with a pull on the control stick and maintained that pull, holding the aircraft in the stalled condition for over 4.5 minutes until impact with the water. Improper crew manual flying response to an unexpected stall condition and unfamiliarity with basic stall characteristics of their aircraft led to the 228 souls aboard all lost, and an exhaustive 2-year search to find the remains. These are all sobering examples of sophisticated aircraft ending up destroyed with massive loss of life, in large part due to the lack of manual handling skills of the crew members faced with the degradation of their normal automatic mode of operation. So why do we look at these case studies here? Well, it had a resounding impact on the industry worldwide. Although there is seldom just a single causal factor to any accident, the loss of control that made these accidents so horrific would most likely never have occurred had the pilots been better prepared to take over manually. So it becomes painfully clear that manual handling, as described earlier, is a critical dimension to the professional pilot's skill sets. The public outcry over the discovery that Air France 447 went down as a result of a loss of control in flight, exacerbated by an inappropriate crew response, accelerated a long overdue response from the industry that was set in motion by the Colgan accident. Andy Pastor of the Wall Street Journal wrote, "The latest revelations, according to safety experts and others familiar with them, are likely to add pressure to revamp training practices to help both new and experienced pilots cope with high-altitude stalls, upsets, and faulty airspeed sensors." That was written in 2011, and shortly following that, a massive reappraisal of pilot training practices throughout the country in the U.S. occurred, and the industry faced pressure from the public and government to address the deficiencies in training that caused these events. Examination of the undue reliance on automation and the conclusion that the incident could have been avoided had the pilots received more training in manual flying and stall recognition. This all resulted in new ATP rules in the U.S., which focused on the undue reliance on automation that many air crews have. All too often during traditional flight training, stalls and upsets are treated as scripted events, where the setup and approach to the maneuver demands more focus than the recovery itself. A pilot untrained on upset prevention and recovery possesses manual handling skills acquired from their traditional flight training. This training, in most cases, is designed to satisfy the respective national aviation authorities' testing standards in the country of training for certification of pilot licenses. In other words, the training is designed for the student to pass a check ride. Great emphasis is placed on procedures used to prepare and configure for a very limited set of stalls on unusual attitudes. Rich Stoll, a multiple-time master CFI aerobatic and published flight training author, stated, "Treated as an independent maneuver unto itself, the whole ordeal, in reference to stalls and unusual attitudes during certification training, is often enveloped in unnecessary melodrama as well. The actual lessons learned, however, are fear and a false association between the stall and slow airspeed. As a result, all too often a poor and dangerous strategy may develop that seems quite plausible, flying faster to provide a larger margin against these stalls that are misunderstood and are perceived as frightening. This shows an inherent weakness in UPRT deficient pilots, or more succinctly stated, a gap of knowledge exists on a critical portion of the aircraft's performance, the stall, which is the leading cause of loss of control in flight. Upset prevention recovery training seeks to close that gap, to fill in those missing pieces of learned manual handling ability through a variety of means. The first step in the process is an expansion of what can be termed book knowledge, by examination and review of those aerodynamic factors that apply to all fixed-wing aircraft. Classic stall recognition and their techniques for recovery are covered. Exploration of applicable performance charts relating load factor, bank angles, velocity, and other aerodynamic subjects is conducted. And case studies highlighting proper and improper use of recovery procedures are detailed. This portion of UPRT is absolutely vital and sets a solid foundation for understanding. The understanding needs to be why prevention and recovery steps are designed the way they are. Armed with this knowledge, the UPRT pilot in training is equipped to execute on-aircraft training using the techniques and strategies that are covered in the classroom. So this classroom session, or I should say the classroom step in UPRT, is absolutely vital and provides a foundation upon which all the future training will happen. The on-aircraft training, if there's flight simulator training involved in the program, but it's absolutely critical. On-aircraft flight training in an appropriate aircraft is the next step in UPRT. An aerobatic capable aircraft is recommended by several different regulatory agencies, including the FAA and the International Civil Aviation Organization, or ICAO. They recommend conducting on-aircraft UPRT in aerobatic category aircraft to expose pilots to maneuvers such as uncoordinated stalls and spiral dives, which would, in a normal or transport category aircraft, put the crew at high risk to enter spins or other loss of control in flight events that could be unrecoverable due to the decreased safety margins in those aircraft types. Aerobatic aircraft have a much higher safety margin and ability to conduct all attitude and all envelope training than other aircraft types, particularly transport category airplanes. This point begs the question, can jet pilots really learn upset prevention recovery in a single-engine piston airplane? Well, the answer is in the question itself. A jet is an airplane, subject to the same general aerodynamic laws as a single-engine piston aircraft. Granted, each has differences in pitch moments with power changes, keel effect, turning tendencies, and yaw damping considerations, among many, many other things. But these differences make up an estimated 5% disparity between aircraft types. With that said, the training industry agrees that type-specific considerations are critical to effective UPRT skill development and must be comprehensively addressed during type rating and recurrent training. But overall, an airplane is an airplane, and virtually all pilots begin their careers in the same kind, a single-engine piston airplane. Upset training is intended to be transferable. It should follow a pilot through his or her career, and thus the tenets taught during early training should be relatable to any fixed-wing aircraft. That said, an aerobatic aircraft is clearly more maneuverable than other aircraft types, has a higher load factor limit, G-force onset rates, smaller turn radii, faster roll rates, and so on. However, most pilots of less maneuverable or more limited categories never truly see their aircraft, or any other for that matter, at the limits of or beyond what they consider normal flight parameters. The closest most get to these parameters is the approach to stall indications during their once-a-year recurrent simulator sessions. They would never dream of using maximum aileron deflection or pushing on the control column or stick before or while rolling out of an upset. Accomplishing these techniques and many more exclusive to UPRT expand the pilot's awareness, their learning horizons, aerodynamic understanding, practical experience, and edge of the envelope experience. Now, a final stage in UPRT is to place the pilot in training in a full flight simulator and practice these upset prevention recovery training techniques in a wide variety of situations. Once the basics of upset prevention and recovery and the general strategies are learned, it is equally vital to allow the pilot in training to experience these strategies in a full flight simulator that more closely resembles their normal flight environment. This allows them to realize fully that UPRT works in any airplane and helps them to correlate the aerodynamic lessons they've learned during upset prevention recovery training and apply to their own aircraft or one of a similar type and category. Furthermore, crew resource management is tested, and UPRT is applied to this kind of environment. Because manual flying doesn't always apply to only the pilot flying, but also to his or her crew members as well. Now, in closing, manual flying can be described as intrinsic flying ability, assumed at least by the flying public to be part of the skill sets of all commercial pilots. If present, even innate skills can be improved upon, polished, and expanded. If these skills are not present, they can be learned. Manual flying skills include everything from basic instrument reference and simple flight control inputs to complex problem solving in a crew environment when time is of the essence. Upset prevention and recovery training is aimed at improving and building upon these basic skills and teaching new ones for the unexpected. In a perfect world, use of upset prevention and recovery training would never be required. But this is not a perfect world, and the unexpected happens every day. So, does upset prevention and recovery training really enhance manual handling skills in professional pilots? Absolutely, and without question it does. In fact, improving manual handling is a core goal of upset prevention and recovery training. This is how I see it. Chance favors the prepared mind, Louis Pasteur once wrote. And upset prevention and recovery training is a critical facet in that preparation for every pilot. So here are the references that were present in this presentation. And thanks for listening. Really appreciate it, and I hope this was very educational to you.